Okay, thank you. Welcome to the panel number 4, 6G Vision, Research Activities and Challenges, Industry Perspective. So this is a follow-up panel actually, the previous one, the same concept. First of all, I'd like to thank Hüseyin Hocam. I'd like to express my gratitude for organizing such a great event. I always believe that this is Hüseyin Hocam's visionary project. He started it 2017, probably planned that in 2015 or 2016. So it's a decade we are talking about. Again, thank you. And the organizing team, Yusuf, Furkan, and Mohammed, I met them yesterday. This panel looks into 6G from industrial perspective. We may simply look into scientific research first on the left-hand side, let's say. And then market is right here, where we have money. So we as academicians with limited funding, money, we just try to survive and get funding for our students or equipment, laboratory. But money is right here, so market. So in this panel, we'll be approaching this market, the money. So scientific research, publications, patents that could be licensable or non-licensable. And if it is a licensable patent, then we got standards and then product. So we'll be focusing on this licensable patents, standards, mostly products or prototypes. We have 3 representatives from 3 major companies in 5G and 6G. I know the 2, ASELSAN and Spark, very well, but InterDigital is not, the company that I have known much. So they have a different business model, actually, the InterDigital I'm talking about. In break, we were talking about the 6G radio with Cem. And we realized that the 2 companies were there somehow. And this was then all about, 3 companies here, they complement each other somehow. They work together, and as far as I see, these 2 guys, Tolga and Serdar, were classmates. So this is how Hüseyin Hocam has a vision to collect 3 complementary companies. I'd like to start with Tolga Bey, and I'm going to read his short bio here. Okay, Dr. Tolga NUMANOİLU was born in Ankara in 1980. He completed his undergrad studies in the Electrical and Electronics Engineering Department at METÜ, Middle East Technical University, in 2003. In the same year, he was accepted to a PhD program as a research assistant in the Electrical and Computer Engineering Department at the University of Rochester, New York. His research focused on designing a scalable communication network infrastructure for next-generation tactical radios. He received his master's and doctorate degrees from the University of Rochester in 2004 and 2009, respectively. He is currently the Director of Systems Engineering in Communications and Information Technology sector at ASELSAN, where he has been working for the last 15 years. He is married and father of 1. So, in the previous panel, there were some specific questions. Here, as we are talking about the company, then we'll have more generic questions, and we'd like to ask the panelists to talk about 6G vision of their companies, research activities in their companies, and then challenges and future trends or technologies that they're focusing on. So we can start with Tolga Bey. I think they have presentations.
Sure, yeah, just to assist the presentation. Before I start, of course, I would like to thank Professor Aslan for inviting me here, giving me the chance to speak to this distinguished audience and be part of this great conference. Basically, I would like to thank everyone who makes this possible, who made it possible, and will make it possible, of course, in the future as well. Well, let's start with our 6G vision. Basically, that is something related with companies' interests and companies' history, and also what's going around in academic research, as well as organizations such as 3GPP. So to present the vision, we have to understand what ASELSAN wants from 5G or 6G, or how it uses 5G, 6G. So for that, we actually, of course, use the same figures and annotations that everybody tends to use. But what I would like to do is to elaborate on how things are actually evolving from 5G to 6G. Seems to be like we are just enlarging the triangle to a hexagon, or no, octagon here probably. No, is it hexagon? Yeah. Okay. So what happens is we already have some of the features. There are great features to be addressed, like mobile broadband, massive machine type communications, ultra reliable low latency communications. So these are still there, but they have different names now. But they will also have different features and more details to be investigated, and more products to be available in these areas as well. So we say hyper reliable low latency communications. Then between like communication and sensing, we have a nice way of doing it together. Like also AI comes into question. How are we going to use it, or how are we going to enable it, as the other panelists addressed? Massive communication is always there, like it gets more massive basically. Connectivity, immersive communication. So how do we utilize, let's say, next G technologies in our solutions? Also, we do have another side to us, which is militarizing next G communications. So just to address these, I'll start with utilizing the next G technologies in our solutions. Basically, what we do is we provide a service to our users, let's say. They are not customers, users. What we do is we actually provide services and applications for their needs, and up to these days, we already changed how the network behaves, or modified how the network reacts to user needs in our previous generation solutions. So we mentioned about our solutions for public safety, where we actually take into account all the feedback from customer and make the changes necessary on the network or on the services so that they are satisfied. With the next G or 5G, or continuing with 6G, we will be always there for public safety, broadband, railway communications, and private networks. Basically, what we are trying to do is, there's a nice reference here. Use of commercial wireless broadband technologies, when appropriate to meet mission needs, can allow military and other federal government operations to use spectrum even more efficiently and cost effectively. So this is something we found on the research area, where people investigated how these programs, advanced communication programs, evolve, and how military or government bodies stay behind them because of all this increased demand on the civilian communications. So there are some tactics developed by others that actually explain how we approach to these kind of communications as well. So I took that as a reference. So we try to adapt to the life cycles, which are still in question. Many people like criticize, are we going too fast into 6G? How about just evolving 5G? Those are valid questions, but I believe, as in all areas of consumer products, iPhone comes out with a new iPhone, which looks like the old one, but still comes out with it, and still it enables something for someone. And those are the things that we look into as well in these kind of communications. So to see what we focus on, actually, basically we have to develop our national waveforms. This is close to what NATO does for all the NATO countries. We have to have secure 5 or 6G communication in tactical area, because the needs of communications, military does not lead it anymore. The leading edge is on the civilian side. Basically the technologies, the user experience, our users, they see in their lives that have great data speeds, low latencies, connectivity everywhere, and they're just telling us, what are you guys doing? Why don't we get these at the military edge or tactical field? So we have to keep up with this. That's why we are really interested in 6G vision as well. Also, what we need actually is high capacity comms while preserving LPI, LPD. There is a keyword that you will not hear again. Low probability of interception, low probability of detection. Basically, the sole goal of making a signal which can be recognized everywhere in the world becomes our enemy in military communications. Basically, we need to hide it as much as possible. But there are tools within the standards, without going out of the standards, there are tools to do that. So we are finding ways to use the standards to overcome the problems that we have in another field. So basically, why do we do this? Because we need public safety should stay in the standards while giving the customer needs and while being flexible in defining the services to our users. But in military, we can use whatever we want, whatever we need, and continue with the rest and design on top of that building blocks and have some solutions that actually 3GPP never dreamed of. This seems like a little bit unfair, but we are doing it. So, waveform design. So we have many fields that we do our research. For example, what we have is we want our network to be boundless. Basically, the picture on your left top, it is a picture of future, not now. Right now, it's drawn with lines and some of the subnets. All the subnets are connected to higher net, and they communicate towards those nets going up and down. But now we aim a flat topology where we have base stations which are mobile. Right now we are aiming for that, although integrated access and backhaul did not go that far in 5G, but we are aiming that. Also on the right-hand side, we are looking into millimeter wave communications for flying platforms, where actually integrated sensing and communications, we call it ISAC because it's easier to say, nothing more to that. But it makes more sense, already makes more sense, and everybody is thinking, why haven't we done this before? Then we look and we have seen examples. We are trying to communicate with radars. We did that, like radar devices send pulses to communicate. We did that as a timeshare. But right now, as our professors explained, we are trying to do it with the same signal, and we're using the same frame structure, same numerology as well. And also, AI is important for us, AI-based waveform. It's a big goal, but we are trying to get there. Satellite communications, like low Earth orbit communications, has to come into place because it has a way of unifying our communications on the field, where you cannot reach the satellite reaches. And like the question mark next to OTFS, it's still in play for us because we have high-speed platforms. We have some problems that maybe OFDM can still address, but not solve it perfectly. We are still looking into that. Also, we have some names that we have, like Tactical, Gigalink, Cell, and Net, which is basically evolution of our approach. We start with link, we make it into a cell, then we have moving cells, like in mobile attack networks, attached to each other. And when we continue with waveform design, of course, how do we use AI for communications? All the things we can come up with is we have channel that's changing, and we are base stations that are moving. We have adversaries trying to make our communication impossible. So our channel conditions are much more contested than the usual channel conditions we face in the civilian life. So we should find ways to overcome these with all the control signaling and everything. All the information there can be harnessed to have a picture like on top left, having a constellation spread all around, and it becomes nicely focused after AI is there. So we'll need to look into that. Also, we have some networks which are already mesh. We have been designing mesh networking solutions for 20, 30 years now because it was a must. We didn't have infrastructure available in our field. There are hundreds of radios who need to communicate, so we already designed some routing protocols which actually back up each other. Also, self-form, self-heal. But these were done with lookup tables or just some ifs, elses, and maybe more cognitive stuff lately, but it will use AI eventually. And to me, AI is more like you have a feeling, but you cannot tell if it's happening or not. AI will tell you if it's going to happen or not, because it goes beyond your perception and extracts the information beyond the capability of human minds. Some really expert engineers or professors will tell you that this will happen, and you will look like, how does he know? There is the connection he made that AI will make in an instant. So that is a little scary, but we'll still have some human contact when making decisions, but supporting decisions, AI's job will be number one. I think number one thing will be supporting our decisions. Also, we have the threat, the adversary, like the electronic warfare guys. They're trying to stop our communications. So to avoid this, what we can do, we can prepare for the worst. That's what we have been doing. We are designing adaptive modeling and coding and modulation, which will overcome the worst type of jamming. But what we can do, we can actually utilize all the information we get from this channel and have the signal strength, signal type, or frequency bands adapt to what's out there. This is like beyond like cognitive radio, if you may say. Just to also cover all the bases, like we have the hardware side to this as well, because all the nice ideas, beautiful solutions are usually meaningless in the money side, as you mentioned, unless you have a solution which can be packaged and sold to customers, which is within the budget of size, weight, and power, also money as well. So what we do the beamforming IC development in-house, basically. What we aim is we want to lower the cost, lower the power consumptions, reduce the size and weight of the products. Also, solve some of the problems that are like just special to us that we face on the field. For example, I mentioned a couple of those, like our channel is more contested. We have adversaries that are trying to trick us, even like not just like jam the communications, but also trick the communications. Also, we need to have in higher frequencies more efficient devices as well. So this is the way we go. Also, we try to stay in the radio business. This is our core business. So we have 5G RU development, which will continue in 6G as well. These are some specs there. Basically, what we are trying to achieve is we need to have control of our radio environment, RF environment, because that's where all the information, or that's where all the capacity starts. I mean, after you define your capacity or information rate, then you can have additional features or additional services, applications that can change your game as well. But it all starts with here. So the definition of your channel bandwidth, how you utilize it, how you use it, basically affects all your other applications. And 6G means actually you get more of this. You get more of your bandwidth, you get more of your frequencies. Now you can mix and match and enable all your applications to succeed in the money business or also in military business as well. And what we focus on when we look at into the future, basically we like the idea of operating in 7 to 15 gigahertz. Basically, this is seen as a critical frequency band. We can understand why, because it's not too high to disable some of the features that we want to achieve. Attenuation is not too bad, it's also good there. Also, the capacities are higher there, like we can have more users there, maybe multi-user MIMO will make more sense there, like for us. Also, antenna designs and other stuff, we can also design with our own capabilities, our own antennas and other devices as well. Well, integrated sensing and communication seems like a good fit for military first, but still we think about railway solutions and think that there is a base station standing there for a train to come. It can still maybe monitor the tracks and see if there is anything on the tracks, while not adding another device or adding another costly solution there. We can also monitor the tracks. This can be one of the goals. Also, distributed MIMO systems, as mentioned, we have many devices on the field. We can utilize this idea as well. Also, the usual AI ML based waveform and embedded software. I'm not going to give more details because subject is out there. Many papers are published. We are following those. We believe that this will be a game changer in the civilian field, and it will be a huge enabler for the military communications as well, because what we don't want is, we don't want our AI ML based algorithms to be used against us, so we have to be more careful using them in our field as well. Of course, RAS is here because it gives you another dimension of utilizing your RF signals like the way you thought it would not be possible. So it gives you some advantage that is there without putting a new device or putting a new unmanned aerial vehicle there. You can just use these technologies to cover your bases, like basically have your signal reaching more places than you could in today's days. Also, what we have to do is we have to find a way to have some NTN coverage added into this. Basically, talking about some satellites is usually good for countries who have many satellites, but we have to aim for many satellites to be able to get those, and we have to prepare ourselves for using our satellites if we ever aim to launch like 1,000 satellites in the lower Earth orbit, basically. So it doesn't go the other way around. You wait for LEO satellites to be there, then you start working. It doesn't work, of course, everybody knows this. What we want to do is, of course, we mentioned first 4 generations focused on people, then we talked about things, bodies, or you can say like devices, machines. We understand that also battlefield has many things that are not online right now in terms of like connected to anything. We'll try to make those available as well. This goes more on the massive machine type communications of the 5G basically. We need to find reduced capability devices. We need to find ways to make our cryptography available there. It's a big issue, as other professors mentioned. Also, we need to see what we can do in sub-terahertz and terahertz bands as well, because this is a field which will enable some of the huge data transfers without going into that much of time or resources, basically. And thank you.
Thank you. We're going to take questions at the end of the panel. The next panelist is Dr. Ahmet Serdar Tan. He received his BS degree in Electrical Electronics Engineering from Middle East Technical University in 2003, and then PhD degree in Electrical and Electronics Engineering from Bilkent University in 2009. Following his PhD, he worked as postdoctoral researcher on coherent optical communication techniques in Chalmers University, Gothenburg, Sweden. In 2011, he joined Türk Telekom R&D and Argela and participated and led EU and TÜBİTAK-funded research projects on wireless communication systems. Between 2014 and 2019, he was co-founder of an R&D company focusing on ICT R&D, consultancy, and machine learning for wireless communication systems. And he was assistant professor in MEF University. Before joining InterDigital, Dr. Tan was with Ericsson Research and developed AI-based techniques for zero-touch operation in 5G NR and 5GC. For the last 4 years, he is a senior researcher at InterDigital Europe in London, with focus on the research and standardization of AI/ML for B5G and 6G air interface. He is leading the Horizon Europe project centric on AI for air interface and leading the university collaborations programs. Dr. Serdar, you can start.
Thanks a lot for the introduction, and as always, thanks a lot for the kind invitation for this for attending this conference. It's a great audience there. Is there anything?
Our TV is going to shut off.
Yeah, doesn't have the AI.
If you want, you can start by talking about InterDigital.
Of course, yeah, I can start. So yes, Professor Kara mentioned that most of you may never heard about InterDigital before, but it's like a pure research and innovation company, like founded more than 50 years ago. And indeed, like in our daily lives, we are somehow engaged with the technologies developed by InterDigital, mostly through your smartphones. So all your smartphones somehow running some technologies developed by InterDigital. Oh, okay, oraya geçeceğim. Okay, thank you. Let's try this. Okay, this one. Oh yeah, so as I said, so most of you may never heard about InterDigital before, but it's indeed in our daily lives because InterDigital is developing like foundational technologies for wireless and video, which is essentially your daily lives through mostly your smartphones. And InterDigital has like global R&I offices in US, Canada, UK, and France, and I'm part of the research team in the UK. So InterDigital is joining us like this 50 years of expertise in wireless and video research and innovation. It has one of the strongest technology and patent portfolios in wireless, video, and AI. And it's developing and sharing its core technologies through standardization and licensing. And as a result, its licenses have been used in like more than 5 billion devices globally. So InterDigital has lots of research leadership positions. So all R&I researchers and engineers are contributing to like journals, conference papers, a huge output there as well. More than 100 leadership roles in wireless and video standards organizations like 3GPP, ETSI, ITU, and MPEG. And for the last 20 years, more than 10,000 contributions to standards has been accomplished. And more than half of the InterDigital employees, like more than 300, there are more than 300 engineers who hold advanced degrees, and most are with PhDs. A little like overview about this business model of InterDigital. So the core of InterDigital is research and innovation, where these researchers and engineers are contributing to the patent portfolio, mostly in line with the standards. And then the patent portfolio goes through the licensing procedure, which is licensed to product implementers like Apple, Samsung, Huawei. This is, as I said, this is not just patent creation. So this patent creation should be in line with the standards development. It should be related to standards research. And with the standards development, then the technology is shared globally. So it becomes a part of the specifications. So that's why the product implementers license the patent portfolio of the InterDigital, and all the income that's generating is always fed back to the research and innovation team. So this is a great innovation cycle that InterDigital is operating on. A bit more details on the areas of focus of InterDigital. So as I said, wireless, video, and AI are the 3 labs in InterDigital. In wireless, the core research is on cellular wireless technologies, 4G, 5G, and 6G. Also, there have been studies, and there are some studies on Wi-Fi and wireless local area networks, but the core part is always cellular wireless technologies. The other focus area is the video research. So what we mean by video research is like video compression, transport, and its enhancement. And examples are like also immersive media compression, transport, and enhancement. And again, the R&I team is developing codecs and media solutions for targeting like 2D, 3D, and immersive video. Another team, let's say lab, is AI lab, and it's basically using AI for wireless and video coding for AI as well. And that's also a core part of the InterDigital research and innovation. And as I said, so this requires contribution across the tech industry through standards. So InterDigital is a key partner in most of the standards related to wireless, video, and AI, like 3GPP, ITU, MPEG, DASH, DVB, IETF, IEEE. So InterDigital is always active and actively following the standardization meetings, standardization cycles, and providing contributions to all these standardization bodies globally. And also there is also a huge collaboration network that's carried through collaboration projects like Horizon Europe. Currently we have like 4 SNS phase 1 projects running. is also part of the software alliances, a part of the test beds and trials like the Photonic project. It's also sponsoring research collaborations with academia. It's also part of establishing some joint ventures for the promotion of the technologies, and also it's collaborating with the academic centers globally. So now I want to a bit move on to some InterDigital's 6G vision with a focus on Isaac. You have heard Isaac a lot today, so because it's bringing, it's promising to bring a lot of new technologies and new potential and new opportunities for the future of wireless communications. So I think I've seen this maybe in every slide in this 6G conference. It's very important because in order to build a patent portfolio of 5G and 6G, you have to follow the 5G and 6G standardization timelines. So pre-6G studies have already started last year, and official start of the 6G studies will be by mid next year with release 20. So currently release 18 and release 19 are like the pre-stages of 6G, where like concepts like AI for Phi is already in the scope of 3GPP. And like a first set of like frozen specifications will be is thought to be available by 2027. So these all like 6G studies follow the ITU 6G framework release. So it is so it's defining the framework. So what should be in the 6G, and all the 6G studies will, all the 3GPP 6G studies will be following the framework that is released by ITU. But having said that, 5G work in 3GPP like never ends. So even if the releases are frozen, there's always there can always be updates. There can always be like bug fixes, like maintenances. So the 5G standardization study will always will be continuing for the next 5 years as well. So I guess it's also discussed. So I guess it's nothing new. So 6G may be a better 5G. So how will 6G make 5G better? So it will be connecting people better with immersive experiences like lower latency, ultra low latency communications, holographic media. It will try to bring in extreme coverage. And 6G will have the potential also to bring into new markets and sustainability like industrial automation, autonomous vehicles and swarms. And another potential market is the low power and batteryless sensing. Dr. Tolga also shared this like ITU again, this IMT 2030 framework. So it is, I think it's a key figure, this hexagon, because it reveals what should be in 6G. So it is improving this 5G triangle framework, which included EMBB, MMTC, URLLC. And 6G will push this further with enabling new capabilities like integrated sensing and communication, so which is the IMT, which is in the IMT 30 framework, integrated AI and communication, which already started. It's like studies and even made into work item stage. So AI for 5G will be in the specs next year. And because connectivity. So these are all will be new capabilities of 6G. So as I said, so integrated sensing and communication has the potential to have a huge impact. So it will facilitate applications and services requiring sensing capabilities like multidimensional sensing for unconnected objects, connected devices, their movements and surroundings. And it will enable use cases like fine-grained navigation, posture, gesture recognition, maybe from your phone, very fine localization, movement tracking, and special information for exercise. So these are all, this can be all outcomes of the studies on integrated sensing and communication. So this, again, Isaac topic will be building on leveraging radio signals to sense objects in the environment, and it will add significant capabilities like, again, high accuracy tracking, localization for maybe factory scenarios, simultaneous imaging and mapping and localization. So these are like, of course, ultimate goals. Augmented human sense, gesture and activity recognition through your phone. So these are all potential opportunities, application areas. And critically, of course, the sensing data can also be used to enhance network operations and services running over top of the communication. So that's why it is Isaac. So it will most likely be built on the existing waveform structures. So I guess the most one of the most challenging parts is to find ways how sensing can be implemented on like the existing 5G framework. But in order to be like promote your inventions or promote your technologies, you have to a company has to be involved with these specification groups. So this is like one of the examples of what InterDigital has achieved for integrated sensing and communication. So our UK team director Alain Murat is also at the ISG chair. It's the Isaac ISG chair, and this Isaac ISG, which is like industry specification group, have been formed from scratch with vice chairs from Apple, Huawei, and like Chalmers University. So there has been a lot of procedures to bring this to life, and it was a great success, which was leading an ISG. Like requires lots of communications, lots of cycles, and lots of proposals, and it needs to be accepted by the EXI board. And at the end, so these are like the steps defined by the ISAC, ISG, define the priority 6G use cases for sensing, develop enhanced channel models for targeting 6G ISAC use cases, and also validating through extensive measurements. Specifying key performance indicators and evaluation methodology is one of the keys. And also it's like lore system and RAN architecture framework for 6G ISAC. Privacy and security aspects of sensing data is crucial because now you have the sensing capability, so there must be some studies on privacy and security. And also, last but not least, some impact, widespread impact on sustainability of these technologies is also part of this SC ISAC ISG team. And this specification group started working like early this year, so it's new, and it will continue its operations. So, and it's such like specification groups are open to collaborate with any institution. So it's free to join, free to contribute, free to follow all the discussions. So these ISGs act like a pre-standardization group, which will direct how the 3GPP study items and work items will look like in 6G. So it's always good to follow such pre-standardization activities. Okay, I think that was all I wanted to share. I hope I didn't take so much time. But
Thank you. Thank you. So the next panelist, Cem HOŞGÖR. Cem HOŞGÖR graduated from the Department of Electronics and Communication Engineering at Kocaeli University in 1998. Between 2002 and 2005, He worked as a sales and marketing manager at Gate Electronics. In 2005, he joined Textronics, where he served as a area sales manager and RF business development manager for Turkey, Eastern Europe, and the Middle East until 2012. During this time, he gave seminars on technology, measurement science at numerous universities in these regions. In 2012, Cem joined Spark Measurement Technologies and began working with Keysight Technologies. Since January 2023, he has held the position of General Manager and CEO at both Spark Measurement Technologies and Spark Calibration Services. Okay.
Thank you very much. And it's an honor for me to be invited as a panelist to talk about a 6G vision, research activities and challenges. As Spark Measurement Technologies, we are a technology company with a strong technological background and measurement science expertise. We design, develop, and sell custom solutions in different industries. Being a technology company, we work on various technologies such as 5G, 6G, Open RAN, radar, EW, EV, EVSE, mobility for automotive technologies, etc. We have another company called Spark Calibration Services, and we provide calibration, adjustment, maintenance to our customers in Turkey and develop metrology softwares. And we are technology partner of Keysight Technologies, and they are US-based test and measurement company with $5.5 billion annual revenue and $22 billion market capital. Regarding 6G, we have a close ties with the Keysight 6G Research Group, and we have 4 6G SNS projects granted, and I would like to talk about 2 major of them, and the first one is 6G Centric program. The goal of the project Centric is to enable sustainable user-centric 6G network through AI native air interface. We have different objectives in this program, and one of them, for example, to develop AI methods for the discovery and deployment of novel and efficient waveform and transceivers, or to validate user-centric ML-based air interface solutions in the lab environment. Another important program we have is 6G Sandbox. It's a 6G test facility with an intelligent, secured, and twinning-enabled open experimentation facility. So it can be reached from 4 different locations in Europe, from Malaga, from Athens, from Berlin, and from Oulu. And some of you may remember, as Spark, we were here in 2022, and that year we have transmitted 36 gigabits of data over the air at 158 gigahertz here at this symposium. And we came back this year with 2 new concepts for 6G. The first one is 6G conceptual radio. So we have a radio, conceptual radio, and the first time we will make the demonstration for AI ML-based sensing for 6G at 144 gigahertz. So I encourage all of you to go to ASELSAN booth, and you can see the platform is working with AI sensing. When it comes to research, as Spark Measurement Technologies, we are working on 6G since 2020. And these are some of the areas we are working on. We are working on waveform design, channel sounding, equalization techniques, AI in phi layer, Mach layer, AI validation, Isaac, and we have done a demonstration for Isaac at Mobile World Congress this year using our solutions. And when we look at AI, we currently see 3 phases in the development and transition to AI, each of which requires sustained multidisciplinary research. In the first 2 phases, we do not need any new signaling or procedures, as they will have an impact on the transceiver algorithms. But when we look at the ML replacing single blocks, ML can be used to enhance or replace single blocks in the receiver side. For example, we can replace physical random access channel or channel estimation, or symbol demapping. This is what we are doing with ASELSAN today at the booth. We have replaced the channel estimator with an AI model developed by InterDigital, and we are comparing that model with the AI model developed by Keysight and the classical receiver. So this is the demonstration we are running at ASELSAN booth. How we are doing it, this is the setup we have. We have system design software. We have designed a 5G system in the software with a TX and RX chain, and then we replace the channel estimator in the receiver with an AI model, and that software platform can communicate with our conceptual radio at 144 gigahertz, so we can see the results in both in simulation and with the real hardware. So we demonstrated that AI-based channel estimator can outperform the classical estimator in simulation and in real world. And as I explained, we use the AI-based channel estimator developed by InterDigital. Another important work or demonstration we have done is to replace multiple blocks in the receiver with a neural receiver. And we have done this demonstration together with NVIDIA at Mobile World Congress this year. How we did it? We have this Open RAN testbed. We have generated uplink signals using our VXG signal generator. Basically, we generated 2 UE signals, and we used NVIDIA's Siona ray tracing tool to pre-train the data. So we did days of trainings, 3 million iterations, using stochastic channel models of urban macrocell. And that ray tracing tool is controlling our channel emulator, and the data from the channel emulator is going to a commercial ORU, and the optical splitter between ODU and the ORU, the data over there is going to the neural receiver developed by NVIDIA in GPU. So what we learned, it was the proof of concept demonstration. And here you can see the dashed green line is the pre-trained data, and we also did site-specific work only specific to Mobile World Congress area and use that models as well. And we gained about a dB SNR. So the concept is working. This is what I can say, and it was the first time, it was the first demonstration under the 6G-centric program. About the challenges, when I look at the SoftBank's press release, I see that they listed different challenges based on from the architectural point of view, technological and social point of view. It talks about the frequency utilization, expansion, network security, etc., etc. But when I look at the challenges from the designer's perspective for the industry, we talk about sub-terahertz bands for 6G, so 10 times bandwidth meaning 10 times the problems we will have. We are talking about AI native platforms, the semiconductor technologies to develop PA, LNA, or mixed signal transceiver circuits on sub-terahertz bands. This is not an easy application. And new forms of antennas and packaging will be also important, like antenna in package, antenna on chip technologies will be important. And here, I would like to take an example. And this is not for the remote surgery, by the way. So what we have here is to model 180 centimeter high full-size human, we need 1 terabit per second data throughput. Do you know how much bandwidth we need to have the 1 terabit per second data throughput? We need 180 gigahertz bandwidth. When I look at the spectrum, I couldn't see 180 gigahertz bandwidth in the spectrum. So what I saw is, if we go to 356 to 450 gigahertz, we have 94 gigahertz bandwidth. So this is for the holographic transmission. But this is the challenge we have. And we talk about AI. AI will be in PHY and MAC layer and for different things, but there are benefits of using AI or in different use cases, like channel state information feedback, or channel estimation, positioning accuracy, or bin management. But there are also challenges will come with the AI, and those challenges will be trustworthiness, explainability, and standardization will be a challenge we need to address. Thank you.
Thank you. Now we can take questions. We have limited time. Okay.
My question is about Internet of Battlefield things. Hold on.
So take a microphone, please.
It will be better to talk with the microphone. Okay. In the Internet of Battlefield, when you change the way of battle, the military guys will adapt to the battlefield dynamics. So when you lack of them, they lose their skills of fighting. What I mean, if a terrorist attacks, for example, throwing an EMP ball to the battlefield, you will lose nearly all your battlefield things. So what will prevent these EMP attacks? Because it's cheaper than your communication tools.
That sounds like a trick question. Is it on? Yeah, can you hear me?
Yeah.
So the thing is, you cannot prevent technology, basically. You can prepare for it. Your question has two ways of answering. One would be out of my area of expertise. I don't know how to prevent EMPs, but one thing, when they happen, what we see in military, they do their exercises as if nothing will be there, first of all. But when there are some aids that help them, like the battlefield of things, like that give them some situational awareness, or some of the things that may not be available to their squadron leader, it will be available because of these battlefield of things. Those things will create some habits. You're right in saying that it will affect them when there will be an EMP. But the thing is, one thing is, I'm just like elaborating now. This is not fact because I have not faced EMPs. EMPs will not be really deployed to affect the soldiers. More big platforms and guns or radars kind of things. But of course, there will be army people next to that, and they will be affected. But we are more thinking about our precautions are more on the device side, where there are like huge devices with protection walls and everything. We are getting some requests like manufacturing our devices EMP resistant. But for the soldier on foot, in the near future, they will have to be aware that there is a threat like this, and they should be using battlefield of things for their benefit, as long as they're there, but they shouldn't rely on them. You're right about that.
Thank you.
Thank you. Another question? Yeah, there's one there. Yeah, here.
Can I?
Ferdi Hocam.
I would like to ask the Tolga Bey. As academics, we are talking about integrated sensing and communication, and we are saying that it should be simultaneously and at the same frequency slot. But when I was talking with the telecom operators, they are envisioned that integrated sensing and communication will be the same package, but not the way as we see. They are talking about it will be either different equipment in the same package, or it will be kind of TDMA. But one thing with the sensing literature, probably we are not aware of what you have done in the last 30 years in the defense industry, and your know-how is like 50 steps over of us. We are kind of trying to reinvent the whole story you already know. So as ASELSAN, you have already done this, or how close you are to go to integrated and sensing communication as we see academics today?
Short answer is no. Long answer will be a weak no as well. But we are somewhere in the process of doing this. Basically, I already mentioned we have been in the same device. We are planning to be in the future as well. The way you mentioned, like device timeshares, or there is a small different package inserted next to it so that it can do the purpose as well. But what we do, we started project with our academia as well. So some of the professors are here as well. So, and the other thing is, we know extensively how to communicate and how to design radars. Basically, the problem is no one wants to give their share of time because it reduces either the bandwidth or the throughput or the accuracy of sensing. So we are trying to find a sweet spot where with this same signal, of course, you can guess it's not going to be as efficient for communication to have that kind of signal that will help sensing. And for a communication signal to be helpful with sensing, it has to degrade some of the features. So first, that's why, being a communications guy, we started with communicating flying platforms. Let's give them some ability to detect their surroundings, like their altitude or some of the flying objects around them. But it will not be a radar which will be a long range or sensing everything like in a tiny bits, because the idea, actually, just to give you what you actually focused on, as the frequencies that we communicate increased, this became a natural solution, because radars, for them to able to distinguish small differences, they already operate on higher frequencies. So now we are there. We can either like challenge us and say that when we work, you should stop, and they work, we stop. We say, let's find a nice soft solution, not hard decoding, but soft decoding kind of. Let's find the solution closer to the capacity where they can little bit back off from their sensing abilities, where we sacrifice maybe some of our frame structure to have some meaningful control signalization while having the sensing as well. Not throughput signalization, because we want our data packets to go fast. But our control signaling can take some damage in order to have some sensing. These are the things that we think, actually.
Thank you. Thank you very much.
Thank you. We can take one more question. By the way, is there anyone from RACE, ASELSAN RACE? I think there are some guys there, electronic warfare and radar. They may speak about that problem.
No radar.
Okay, yeah. So yeah, there's one out there.
Hello, my question is going to be for Mr. HOŞGÖR. According to that demo you did in the last conference, and the same demo is also here this year. I saw it again. Don't get me wrong, it's always get me happy to see that demo. It's really cool. But the demo itself, it uses 2 horn antennas, very directive antennas, and we had a discussion on the last conference, like you're using a very large bandwidth, like what's the channel that you're receiving, like how many multipaths you're currently having, and you had a lot of multipaths even in that scenario, and you were doing a time domain equalization. So my question is, let's say that, how is it going to be commercialized? So by commercialization, I mean, of course, it's still too early. You don't really have anything to go for commercialization, but do you have any vision how to do that? Like, for an example, what bothers my mind is, if I have a system like your demo in a very precise setup manner, it's going to work for sure. But when I give this to a customer, this kind of sub-terahertz technology, this kind of communications technology, user would also have to fine-tune its system to make it work? Or there are some visions that you or your collaborators are planning to do something for the user experience?
Okay. It's a good question. So the difference between the 2 years ago, we have done the first demo with a different kind of setup. So the setup was big. And if you look at this year, it's small size, like it's a conceptual radio. It's a new, actually, concept. And we can add DSP block. And the setup right now can generate 100 gigabits of traffic at 144 gigahertz. I mean, this is the first difference between the two. And of course, it's not easy to design sub-terahertz systems because you have to pay attention to SNR performance and consider about everything. And you're right, so we have the up converters and down converters, and we have the antennas, but you cannot see right now an amplifier and LNA in that setup. And we did it on purpose because we wanted to see the raw performance of the solution, okay? So we can easily add waveguide amplifier into the system and make the signal stronger and much better. So regarding the solution like this, what we are doing is, if you need a solution like this, we work together and we understand your requirements, okay, in terms of SNR, in terms of EVM performance, in terms of everything, and then we help you to build that system. This is how actually is working.
So by design, it's always going to be a custom-made solution according to the customer.
Yes.
Okay, thank you.
Okay, thank you. We can take one more question, but if it is directed to Serdar. Serdar hocam, just wait.
As InterDigital, you are doing great job for the patent portfolio, and I am following closely the company. Recently, I saw lots of AI for communication engineering position in the InterDigital. So what is your vision for that? You know, we already discussed a lot. Do you see a future AI in the physical layer as the patent holder, most of the standards?
Thank you. That's a great question. Indeed, like AI for communication is already in the standards, so it will increase. The pace will increase. The people, the researchers that should be there, that who can design AI for communications is there, because indeed it started even like last year, early last year. The release 18 started. It included concepts for AI for physical layer, indeed, and it was a bit. I think it may be a surprise for most, because like applying AI in the physical layer in 3GPP looked very early to most of the industry and even to researchers or academia, right? So yeah, it started like last year. It's focusing on AI for CSI compression, AI for beam prediction, AI for positioning prediction, localization. So it's already there, and some of those have made into the work item, which means at the end of release 19, AI will be officially in the specs. It's not like you're standardizing the models, but there are a lot of running around AI in physical layer. It's how you transfer the model, how you make the life cycle management, how you even collect the data. Those are all like fundamental topics, and that can directly go into standards. So, so this is a beginning, and I think AI for wireless will be there and grow. Yeah.
Okay, thank you.
Okay, thank you. Let me ask one more question to you, Serdar hocam. How much of the revenue comes from, you know, the patent, licensed patent in InterDigital, approximately?
100%.
So good. I know approximately. So what do you suggest to industry here, in Turkish industry? You know how they work, and the first thing they have to do to, you know, develop some licensable patent.
Yeah, I mean the most important part to license a patent, that it should map to standards. So if your patent is not mapping into any standards.
Now I'm asking about development stage, not the standardization.
Yeah, I mean like in the development stage.
There's a quality there. I'm talking about the quality. How to start with, you know, high quality patents that may be licensable.
Yeah, I mean again, like to have like high quality patents, again you need like a good team of researchers. Funding and time, because the return that you get from the patents is like you get the return in 10 years. So if you invest in a patent, getting the grant of the patent take at least 5 years. So that patent to be implemented by a manufacturer takes another couple of years, and then you can license it. So it's so as I said, it requires funding, time, and good researchers. Yeah, that's the
Thank
key.
you. Thank you very much for all panelists. And this ends the panel. So we have a lunch now, I think.
Before we go to the lunch, we'd like to present some gifts for our panelists, but we'll ask the previous panelists to to give the gifts. Okay, so we'll just mash them one by one like that. So you. Okay, Lütfiye Hanım, we can start with you. To Ali. Okay, all right, we can do it. Okay. Tamam. Okay. All right. Let's start with
Dear guest.
No, you're gonna get a gift. You're gonna get a gift.
Dear guest, while we are in the break, you can see the Radio Fest area and the stands.
This way, actually, we are gonna also establish industry-university collaboration. A step towards that. Okay, Berna Hocam, you are next. The gift is over there. And okay, or to Tolga Bey. Doesn't matter. Tamam. So we also have, don't forget about the Radio Fest. There are some demos out there, student demos, 6G Radio Fest. So when you have time during lunch, during the break, you can visit. It is next to the elevators on your right. Okay, so Sinem Hocam, buyurun. Hocam siz buyurun şimdi. Cem Bey. Evet. Evet. Ya düşündük ne yapalım diye aklımıza bu geldi yani çünkü. Böyle hep aynı boyut oluyor, kayboluyor. Evet. Evet. Okay, so thank you again, for the panelists for the great presentations. So let's go to the lunch. So we'll be all together in the lunch, interact with each other. Time for